on page 44. So just remember, so any of the prior fall break points on the tests or quizzes, I would like to have anything prior to fall break done. So if you come in and get half those points back, I'd like it done by, what do we say, Friday of next week. Would that give you enough time to?
Yes.
That way I'm not having to go back so far in time. So a week from Friday. So if you feel that you want to go over any old quizzes, come see me. But anything prior to break, let's make sure it's done by a week from this coming Friday. Okay? Sound like a plan? All right, so we are kind of a third of the way into this chapter. So this is section 2.6. And we actually stopped at a pretty good spot. Hey, Bob. And we're going to talk about regression models. So again, I'm on page 44 in order to get that. All right. All right. So we have talked about how Desmos works, how we can plug stuff into Desmos in a very bad representation. But let's say we had stuff like this. It appears that it's some sort of linear regression model. But things that I want you to kind of focus on this type of thing is our regression model, our line of best fit, is we're looking for a line that models the data the best. But realize there's a vertical component distance to each of the points. And I just kind of made up something arbitrary. Okay? So remember, we were looking at the R values. The R values are between -1 and +1. The closer they are to -1 and +1, the better. If the R value is negative, that means the slope of the line is negative. The R value is positive, means the slope of the line is positive. If it's a 0 R value, that just means there's no correlation to our data at all. So couple things to kind of think about. When do we have a good R value? And remember, the R value is, like it'll give you like a 0.93. Okay, so it could be close to 1. So think of the R value, whether it's positive or negative, doesn't really matter. Think about if you were taking the hardest class in the world, would you be happy with that? If you had like a 0.81, would you be happy in the hardest class you've ever took getting an 81% on a test or quiz? And I'd probably say yeah. Okay. Now, the closer you get to 0, are you happy with a 0.32 or 32%? No. So think about where you would be, happier with information. Okay. So each of our data points are observations. And they have, let's see, it says on page 44, each of the data points are numbered 1 to 20. They have above to help us discuss the relationship between the various data points and the regression line. You will note some data are above, some are below. Okay, so just kind of goofy. These values are above, these values are below our regression line. That's really all we're talking about. Okay, so each data point is an actual observation. In other words, the residual or the individual number 11 produced a reason to score of 8 and creative score on 7. This result and recorded in the scatter plot along with the 19 other individuals. The regression line absorbs all of those observations produced through there. Okay, let me see. I'm just going through. This is all stuff we should know. Okay. And I'm going to get a crick in my neck if I stay sitting here. Moving up to my other table. All right. So let's talk about some residuals without using a highlighter. So the residual is the difference, means subtraction. So it's difference between the observed value and the predicted. Okay, so let's see what that actually means. So, our conversation's coming to a halt, or are they going to continue? I guess I'll continue. All right. So, let's say that pink dotted line's our line of best fit. The purple dots are our data points. Let's say this has some R value that is 0.87, so 87% on a test or quiz. Pretty good. I like it. Sorry, I'm interrupting the conversation. I apologize. I'm being rude. Oh, he just went there. So, all right. So, talk to me. Let's talk about this value here. Is there a vertical distance that's right there that goes with it? Okay. Let's talk about this value right here. Is there a vertical distance here? Okay. So, on our line of best fit, so remember on Desmos, we're going to use this, which, let's just say this line of best fit came out to be something like this. 2x plus 1. Okay, let's say that's what our line of best fit came out to. So we could use this to predict values. But let's say I picked this point right here. Let's say that's the point 3 in this direction. If I take 3 and I plug it in for x right here, I would get that this would be at 3, 7. Okay? Or, I'm sorry, this is at 3, 7. But this value here, the actual data point itself is, let's say, at 3, let's say that's at 3, 7. Let's say this one is at 3, 4. Okay? So you're in the same x direction. You have a predicted value, but you have an actual value that takes place. So there is a residual value that is above the line that we have to focus on. Okay? It's not because we did something wrong. It's just our line of best fit, after you plug a bunch of data in, is going to fit along the line of best fit. Desmos is going to find that line of best fit for us. But we can take the same x value and plug it in, and depending on our data versus our line of best fit, we can get 2 different y values. And again, it doesn't mean something happened wrong. It just means, hey, something happened. It's off a little bit, and that's okay. It's called the residual. Okay, so the residual is the difference between the observed value and the response variable and predicted value. Visually, the vertical distance between a data point and the regression line, distance put in quotes here, because in geometry the distance between a point on a line must be perpendicular, but it's not here, so that's kind of over and above. So in the diagram on page 45, as you can see, there are 3 observations below the line and 6 observations above the line, but the residuals for the observations below the line are larger. It's interesting to note that the sum of all the residuals below the line will be equal to the sum of the distances of the ones above the line. So remember when we're talking about the R value, okay? If we had this line of best fit with these data points, this could have an R value of 1. Okay, meaning I have these residual values here, 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 here. It's a vertical component to these. So the values on top and the values on bottom, when we add them together, come out to a very good number, meaning that the distances kind of cancel each other out. There is the possibility you get some weird obscure value way up here, and that vertical distance is going to change this R value significantly. It's going to change that R value to be closer to 0 or approaching 0 versus approaching 1. Okay, so those are a few things. So can you predict and can you observe? Okay, if we predict something, we're using our line of best fit. Okay, if we observe, we're looking at the data. Again, that talks about if I were to say, hey, I want to know what this point right here is. Let's say there's some X value I have to it. That X value corresponds to a Y value here for a prediction. But if I do an observation, let's pick that's a good pink color. If I did an observation, notice this. We get a different Y value. So the pink is an observation. So if you're looking at your data and someone said, hey, what happens to our data at X equals this value? Oh, my data shows this from my T table, okay, or my XY values. If I says, hey, let's predict something, then we would use our line of best fit. So that's kind of the difference between the two that we're trying to reach for. So a prediction is once we have gone into Desmos and we've done the table, and then we do y sub 1 tilde m x sub 1 plus b. Remember, the tilde is to find the equation on Desmos. Okay? So if they want to make a prediction, hey, what do you think is going to happen if the temperature is 41 degrees outside? You know, how many people are going to go to the game today? There's a game today? No, I'm just making this up. Okay? So their prediction could take place. Could your prediction be a different number than your observation? And the answer is yes. The observation would be let's say you're looking at some T table, and we have 1, 2, 2, 3, 7, and then we have 5, 8, 9, 10, and 12. So let's say we wanted to do an observation. What happens at 2, or what happens at 3? And the answer would be, well, 10 happens there. Okay? If I wanted to know what happens at 3 and I had the line of best fit that was already there, so what would happen if I wanted to do at 3 here as a situation? So I'm going to go 2 times 3 plus 5. So that's 6 plus 5, that's 11. So I get a value of 10 over here. With my data, I get a predicted value of 11 over here. What one's right? They're both right. It's just, how are you looking at your data? Should it be the prediction, or should it be just an observation? Okay, so I think I've taught enough. We can figure out, let's see, that was 2.6. What page is 2.6 on? Anyone have a shot? 147. So I'll give you the rest of the period to work on that. Let me know if you have questions. So page 147, 148. And happy to help you on that if you need any help. Let me start.